Hi guys, today I'm going to show you a new tool that we're going to use to make math more concrete, more hands-on, so that we can figure out things that might be a little bit complicated when they're abstract and just numbers. But if we use these tools, we can make them a little bit more graspable. So this tool is called BrainingCamp, and it's a set of virtual math manipulatives. And we're going to use today the ones called color tiles. So I'm going to click on this icon and open up the color tiles. And because we are working with arrays and we're doing multiplication, I'm going to draw your attention to this little icon down here. If I click that, I get an array, and I can move it around, and I can change the shape of the array, the size of the array. So I can make it, for example, an array that represents 2 rows of 5, right? And that we would write, if we were writing a math equation, we would write 2 rows of 5 equals something, right? We've been talking about how this multiplication sign, we can read it as rows of, I'm going to try to write with this. It's a little bit hard to use this tool to write with. Rows of, or we could also say groups of, right? Groups of. But when we're doing arrays, we're talking about the rows, right? So I have 2 rows of 5, and I'm going to fill those 2 rows of 5 up with these color tiles. I'm going to use red. So I put 1 in, and then I can just keep clicking on the side here to fill it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I needed 10 color tiles to fill in this array of 2 rows of 5. Looks kind of familiar, doesn't it? To me, it's reminding me of a 10 frame, which we used a lot when we were doing addition in first grade, and maybe a little bit in second grade. But anyway, so we can take this array now and we can test out the commutative property of multiplication. Now, the commutative property tells us that we can take any 2 factors, or I guess it could be more than 2, but we can take the factors in a multiplication equation or a multiplication number sentence, and we can flip them around. We can move them around, and we get the same product. So 2 times 5 is the same as, actually, let me do this a little bit further down, is the same as 5 times 2. We're going to get the same product, right? And up here we said we had 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know the product is 10. So if we switch the factors and make it 5 times 2, we're going to have the same product. We're going to have 10. Now let me just kind of test that out with these manipulatives. So I'm going to go up here and I'm going to grab this array. I just do that by kind of highlighting it with my cursor, dragging and pulling. And then I can copy it by using this icon up here. I click it, it has a little plus sign. Click on that and it copies it, and I can move this copy over here. And then I can manipulate this copy. I can grab a hold right here and I can change it into 5 rows of 2. 5 rows of 2. And then I can move my color tiles in and see if it's going to fill this up, or if I have extra, or if I have some left over, and test my theory, the commutative property, that they're the same. And look, they are. I have this all filled up, which means I have 2, 4, 6, 8, 10 squares or tiles in this array as well. So that's one way that you can play around with color tiles to test out the commutative property of multiplication. Before I stop here, I want to show you one more thing, though, about skip counting and how we would write the skip counting for these 2 different arrays, okay? So this first one is 2 rows of 5 or 2 groups of 5. So 2 groups of 5, the groups of 5, means we need to count by 5s. So we skip count by 5s. 5, 10. We're only going to count 2. 1, 2 groups. 5, 10. That's how we would skip count. Now on this one, we have 5 groups of 2. So we're going to skip count by the groups of, by the 2s. Okay? So we're going to go 5, I'm sorry, excuse me, 2, 4, 6, 8, 10. Oops. I'm saying one thing and I'm writing another thing. Let me try that again. 10. Okay? So we have 1, 2, 3, 4, 5 groups of 2. 2, 4, 6, 8, 10, if I were skip counting. Now, what I'm going to ask you to do is to come up with an array that represents these problems. You can do 2 of these. You can actually choose one of these, and then you'll send me the picture of it. And then if you want more practice, you can do the rest, okay? But I want you to do at least one that you share with me as your homework, okay? So you can do this array, 3 times 4, or you can do 7 times 5. That's going to be a big array, okay? And you can show those to me just like I did here. And once you do that, once you've done all the work like I just did here, I made one of the arrays and then I transformed it into the other array. I wrote the number sentence with the 2 factors in the product. And I wrote the new number sentence with the 2 factors in the product. And I did the skip counting. Once you do those 3 parts, array, transform the array, equation, transform the equation, skip counting, transform the skip counting. Once you do those 3 things, then you can go over here where it says share, click on that, share, and you can link, get the link or code. And you see this here, this share code, that is what you want to copy. So I'm gonna just go like that and I'm gonna copy it. And then you can, let's see, what does this do? Oh, you can copy it to your clipboard by just clicking on that as well. Okay, so you can copy it to your clipboard, and then when you are in Seesaw, where I'm going to post this activity, you can link it in there for to turn in your work, and then we'll be able to go into Seesaw into BrainingCamp together and open it up and manipulate this, and it won't just be a static image. We can still play with it together and talk about your thinking and work through that together. Okay, so that is the work that I would like you to do, and I will look forward to seeing your results in Seesaw. Okay, bye guys.